The natural logarithm is another one of these special logs. Remember that we have Euler's natural number e, which is about equal to 2.718. So when we're talking about the natural log, that's going to be the log base e of some number. And how we denote that as being the natural log is using ln. So we would say ln of x, or the natural log of x. So if we want to solve an equation like e to the x is equal to 8, in order to get rid of the base, we use the log. So we'll take the natural log of e to the x is equal to the natural log of 8. That will get the log and the base to cancel, so that we have x is equal to the natural log of 8. That's the exact answer. And if you wanted an approximate decimal for that, going to your graphing calculator, you get 2.079 using the ln button, which is generally right next to the log button, the common log button. We could also solve this logarithmic equation. The natural log of x minus 8 to the fourth is equal to 4, using our natural numbers and understanding what the natural log is. In order to get rid of a logarithm, we have to use a base. So we would say e to the natural log of x minus 8 to the fourth is equal to e to the fourth. Because the base of the exponent and the base of the log are the same, they're going to cancel each other out. We'll be left with x minus 8 to the fourth is equal to e to the fourth. Of course, since we're dealing with the fourth power, we could take the fourth root of both sides, getting them both to cancel. X minus 8 equals e, so x is going to equal 8 plus e, which is about equal to 10.718. We've also used the natural number e in the continuously compounded interest formula. So the natural log might be helpful in situations like this as well. So here we have that Angie deposited $1,000 in an account that yields 4% annual interest compounded continuously. How long will it take for the account to be worth $10,000? So first we grab that continuously compounded interest formula, that A is equal to principal times e to the RT. And we start filling things in. Since the initial investment is $1,000, that's the principal. And we want to find out how long it's going to take for it to be worth $10,000. So that's going to be the amount in our account at the end. We're given that the interest rate is 4%, so 0.04. And we want to find out what the time is going to be. So here's the situation that we have, or the equation that we have to solve. And we're going to go through it in a very direct way. First, we'll get rid of that 1,000. Since it's being multiplied by e, we're going to divide by that 1,000 to get rid of it. So we have that 10 is e to the 0.04t. In order to get rid of the e now, we're going to use the natural log on both sides. Base of the log and the base of the exponent are the same, and that's why they'll cancel. To keep things accurate, I'm going to leave that as natural log of 10 for right now. And the last thing that we'll have to do is to divide by that 0.04 on both sides to get t alone. Now we have that t is going to equal the natural log of 10 divided by 0.04. And it's at this point that we've got to go over to the graphing calculator to evaluate that. Our natural log of 10 is going to be 2.3 about. And so when we divide by 0.04, we're left with 57.564. And remember, when it comes to word problems, numbers aren't numbers, they're measurements. So this 57.5 is how long it's going to take the account to be worth $10,000. So that 57.5 is 57.564 years.